Okay, gang, moving on to question 10. I do want to go back to question 9 and back to this idea of Markovnikov. And he talks about the rich get richer. Okay, so the question applies to hydrohalogenation, because you're adding an HX, an H and an X, and it's also applying to hydration. Let me clean that up a bit. Let's go HX over here, just for spacing. So the question is, where does the H go? Where does the X go? X should be in green. It's a halogen. There we go. And hydration. Adding water. But again, I want you to look at it a bit different, as adding H with a hydroxyl group, OH. Okay, and when we add a hydroxyl group to an alkene, the final product's an alcohol. Okay, so as I said earlier, you don't have to know the nomenclature. Now, if we look at these hex 2-ene and hex 3-enes way up here, we notice that the carbons have an equal number of hydrogens in either case. So it's possible for that hydrogen to go to either carbon 2 or 3 for hex 2-ene, in which case the bromine would go to the opposite one. Okay, so if we read the original question, right, what could produce 3-bromohexane, i.e. where could it come from an addition reaction? These are the two possibilities. Okay, and it's to do with the fact that Markovnikov rule doesn't even really apply in this case, because the hydrogens on carbon 2 or 3 for hex 2-ene each have one hydrogen, and the same applies for hex 3-ene if the both carbons have one hydrogen, so it's kind of a 50-50 chance that hydrogen is going to go there. Okay, so either of these could lead to the production of 3-bromohexane, which was our final product. So let's take a look at what's going on with the reactions in question 10, and I just want to make some room here because there's 2 spots. There we go. Okay. So pent-1-ene reacts with water and a catalyst. So you need catalysts to drive these reactions. Catalyst is a substance that makes a reaction go faster. Okay, so pent-1-ene. Predict the products of the reaction that occurs when the following reactants are combined. And we're going to have to see if Markovnikov's rule applies. Okay, and for this, I think I'll do the full structural. Pent-1. Okay, so let's check it out. Let's clean that up a bit. Oops, sorry. Alright, so H down to the C. Got an H over here, double bond. The CH, so that's the second one. 1, 2, 3, 4, 5. And there's your pent. Okay, so that means this is C1 and that's C2. So which one's richer? C1 has more hydrogen. Okay, well, what are we adding? Water. And remember, look at it like this. A hydrogen covalently linked to a hydroxyl group. Okay, now for the products. See, Markovnikov's rule is going to apply here. Markovnikov's rule applies. Okay? So this H is going to go to C1 for most. Now, when I say most, let's pretend we're reacting 1 mole. Okay? And if we remember mole, well, that's 6.022 times 10 to the 23 molecules in this case, right? So that's a lot of molecules. So the idea is this. That H, that blue H of water, is going to go to carbon 1. Okay? So then what we can do is we can say, well, we got what's called a major product and a minor product. Okay, so here's our major product. So most of that mole, and again I'm going to draw out kind of a combination here so you see what's happening. Okay, so the rich get richer, meaning that blue hydrogen's going to land on carbon 1 most of the time for most of the mole, right? Most of those particles, which means that for the rest it's going to be the other way around. So in this case, the OH, or hydroxyl group as it's actually known, is going to land on carbon 2 more often than not. Okay, so 1, 2, 3, 4, 5. There we go. 1, 2, 3, and I'm just going to condense these 4, 5. Okay, and we'll just super condense those because they're not involved. Now this major product is called pent 2 ol. So OL is our product name for alcohols. Okay, so that's hinting at what we're going to be learning about when we get to alcohols. Now, a tiny amount, and again, I don't know how much, but some small fraction, because Markovnikov's rule is going to apply in this case, are going to land on carbon 1. So they call that the minor product, just meaning not a lot of those are going to form out of that mole. Basically the rest of the mole. But most of the mole is going to be pent 2 ol. So I'll just draw that H that came from the water, and I'll draw the super condensed form for the rest just to save some time. CH2, CH2, CH3. There you go. So this thing would be called pent 1 ol. Notice how I dropped the A. Okay, now let me make some room down here for the next question. There we go. Should be good enough, I hope. Okay, chlorine gas is bubbled through 3-methyl cyclohexene. Okay, so we've got hexene, alright, and then we've got chlorine gas. Well, chlorine gas is just Cl2, right? So 3-methyl cyclohexene. Let's, yeah. So 3-methyl cyclohexene plus chlorine. Now chlorine's like super reactive, right? So 3-methyl cyclohexene. Let's draw this guy. 1, 2, oh, that's sloppy. 2, 3, 4, 5, and 6. That's good enough. 3-methyl. So that means a carbon 1 to 2. And there's our CH3. Like that. Let me clean up this end here. That didn't help. Oh man, I'm making it worse. Start over. Okay, this might work better. There's actually graph paper you can buy that has, it's basically all hexagons instead of squares. So you can draw these molecules. So there's your double bond. And here's our CH3. So 3-methylhexene, cyclohexene. Right? Notice we didn't have to say carbon 1. So we don't have to actually put that. Okay, so now we're just going to add chlorine. This one's actually easier than you think, because Markovnikov is not even a thing, because we're just adding chlorine. Alright, now, so we get that there, boom, to the boom, down, there's our methyl group. And sometimes you do these combination diagrams where you show the CH. And sometimes you don't. But the Cl is going to land there and going to land there. Okay, so what is this animal called? Let's play with it. 1, 2, 3, 4, 5, 6. Or we start numbering with the methyl. 1, 2, 3, 4, 5, 6. Now, which one's correct? When you don't know, do them both and see what comes out. Okay? And so let's play the game. Here we go. So, if we're doing blue in that direction, so clockwise, this thing would be called 1, 2 dichloral dash 3 methyl cyclohexane. That looks like an E. Sorry about that. Or if we're going red, well, then we're going to call it 2, 3 dichloral 1 methyl cyclohexane. Hexane, sorry. I might have said hexene earlier as well. I'm just getting tired, that's all. Okay, so here's the deal. This is the preferred one because it's going to put the 1 and 2 on the one that comes alphabetical. The numbers are equal either way, 1, 2, and 3. Okay? So this is the favored choice for that name. Okay? And we'll give that one a big X. Nope. So, nope. And yup. Okay. That's it. Okay, question 10. Signing off.